Hi, geometry. This video is going to go over section 1.6, classifying polygons. So there was another quick video, hopefully you watched so you knew how to assemble your foldable. So we're just going to start. We're going to just turn the page here and go over just what is a polygon. So a polygon, it's a closed plane. It's a closed plane figure formed by 3 or more line segments called sides. And each endpoint of the sides are what we call vertices of the polygon. Or non-plural would be vertex. So we have our sides and then we have our vertices. Then we have what's called an n-gon. An n-gon is used to name a polygon with n sides. So we have some of the 8, or actually there's going to be 9, I'll give you one more, common names for certain sided figures. So if we had something like an 11-sided polygon, we call that an 11-gon. A 13-gon, 100-sided polygon, a 100-gon. So for example, if the number of sides here, we say if the n equals 13, we would call that a 13-gon. Now we have 9 common ones that we use all the time, and we don't say 3-gon or 4-gon. So we start with the 3-sided figure. That's your triangle. Your 4-sided figure is called a quadrilateral. Any other name is a more specific name. Just the general name for any 4-sided figure is a quadrilateral. A 5-sided figure is a pentagon. A 6-sided figure is a hexagon. A 7-sided figure is a heptagon. An 8-sided figure is an octagon. A 9-sided figure is a nonagon. A 10-sided figure is a decagon. Just think of decade. And the other one that's not on here is a 12-sided figure, and that's what we call a dodecagon. There we go, dodecagon. Now, anyone that's not up there, such as a 13, 11, and anything larger than 13, that's when we use the number and then we call it gon. But otherwise, if you're given any of these 9, these are the names we use for their general name instead of 3-gon or 4-gon. We use triangle or quadrilateral, etc. Now, they're closed figures, meaning there's no holes in them, if you notice. It's a closed plane. They have vertices, they have sides. Well, we can also call them by whether they're what we call convex or concave. A polygon where no line that contains a side of the polygon contains a point in the interior of the polygon would be what we call a convex polygon. So they could look something, I'm going to draw some examples here. These are all convex. Triangle. And all the shapes on the other side when we were giving them their general names, those were all convex. Now, concave means it's not convex. And how you can tell is somewhere it's concaving, it's caving into the shape. So you see how this is caving into the shape. Something like this is what we call concave. So anywhere you see that caving into the shape, then we call it concave. So right now, try the first 8 here. Tell whether the figure's a polygon. If it's not a polygon, you're done. If it is a polygon, you want to determine whether it is convex or concave. So I pause the video and come back and check your answers. Well, everything has to be a nice straight line, so because of this curvature, this is not a polygon. Number 2 is also not a polygon because it's got lines going through the middle of it. The third one is a polygon, and it is convex. So this is a convex polygon. This one here has 6 sides. It is a polygon, it's a hexagon. Not only that, it is also concave. So this is a concave polygon, and we're going to call this the hexagon because it's 6-sided. We'll do that on the number 5 too. Sorry, we'll call that 5-sided figure is a pentagon. So the word concave or convex, it goes in front of the general name for how many sides the shape has. So a convex pentagon, a concave hexagon, this right here is 7 sides. It is concave, it's caving in here. So this would be a concave. And then a 7-sided figure is a heptagon. So concave heptagon. This one here has 10 sides. Again, it's concaving, it is a polygon, but this one is a concave decagon. Now this star here is similar to the one before, except that it's got lines going through it, which means this one is not a polygon. Only has sides, nothing that goes through. And then the heart, again, not a polygon because it's got curved sides, just like the very first one that had one side that was curved, like a circle. This is not a polygon. So if it is a polygon, we put whether it's concave or convex first, and then we use the name of the actual shape. Now, on these last pages, we've got 3 important words: equilateral, equiangular, and regular. Equilateral means it's a polygon in which all sides are congruent. And the one we're most common with that we hear all the time is the square. Equiangular means it's a polygon in which all angles are congruent. Again, a square is equiangular, they're all 90-degree angles. And then a regular polygon is a polygon, that is convex, so nothing caves in, equilateral, all sides are congruent, and it's equiangular. All angles are congruent. So we're going to look at these shapes here, and we're going to classify them by their sides. So we're going to use that general name that we did back on the first pages. Then we're going to tell which terms apply, whether it's lateral, equiangular, and also regular. So I'm going to start with this very first one. This one has 7 sides. All 7 sides are congruent because they have that tick mark. All these 7 angles are congruent. So this is both equilateral and equiangular. So we use that word regular, and that says that it's both, and it's convex. So this here is a regular, and a 7-sided figure is a heptagon. And it goes in front again. So if you're talking about convex or concave, that goes before the heptagon. If you're talking about equiangular, equilateral, and or regular, that goes in front of the name as well. Now this particular one has all tick marks. There's 4 sides. So it is equilateral, not equiangular because they have 2 pairs of different angles. So this one is what we call an equilateral quadrilateral. Here we go. Now the next one is a 3-sided figure. Not all 3 sides have the same tick mark, and all 3 angles don't have the same swish. So this is just a plain triangle. Then the very last one is not equilateral because these two sides have 2 tick marks while the others all have 1. It also is not equal angular because these here don't have any swishes, so they're not congruent with anything, at least these other 4. So this is a six-sided figure, and we just call that a hexagon. Alrighty, and then our last examples down here. So what it wants us to do is find the x. Sorry, my directions got the covered there a little bit. So because it's equilateral, I do know that these two sides are congruent, and that's because they each have 1 tick mark. So that means I can set my 7x minus 18 equal to my negative 3x plus 67. Solve for x. So if I decided to move my x's first, you can move the constants first. Got a lot of choices here, and you can always use a calculator. Add 18 to both sides. So I get my 10x equals 85. Divide both sides by 10. X is equal to, well, I can leave it as a fraction in simplified form, which is 17 halves. Or because it is a terminating decimal, I could say x equals 8.5. The rule of thumb is that if it's not telling you to round, and they definitely want to know the true value of x, so they don't want you to round, then sometimes the simplified fraction works. And if you can do it on your calculator, and it will actually change any decimal to a fraction. So we'll go over that later on this year, but you can always ask me in class too as well. Now here we have the same thing. We've got these tick marks, so I can set them equal to each other. So I can set my 4x squared plus x minus 37 equal to negative x squared plus x plus 43. So what I want to do, because we've got a quadratic, I want to get everything over to the left. So I'm going to add my x squared. I'll add to my x squared over here, 4x squared. Subtract my x. And then I'm also going to, well, let's just start with that first. Let's just move the x squareds. And when I do that, I get 5x squared plus x minus 37 equals x plus 43. Now, once I move over this x, I'm going to see they disappear, and I'm left with a 5x squared minus 37 equals 43. Well, because I don't have an x term, but I have an x squared term, I want to move this over to the right. So I'm going to add my 37 to the right. And I'll now have my 5x squared equals 80. Well, I want to isolate x squared, so I'm going to divide everything by 5. And I'll get x squared equals 1. Let's see, 4, that would be 16. This is 3. And when I take the square root of it, I'll get x equals both positive as well as negative 4. Because when I square a value, if I have 2 negatives, it becomes positive. 2 positives become a negative. Now the very last one. The vertices of a figure are given below, A, B, C, D, E, F. We're going to plot and connect the points so that you form a convex polygon, and we're going to classify again that figure. So I'm just going to plot 3, 0. This is going to be my A. Then I have negative 2, positive 3. There's my point B. Then my 1, 4. There's my point C. My D is 1, 2, 3, 4, 1, 2, 3. There's my D. My E is 3, 0. And my F is 0, negative 1. So I'm just going to connect my points here. Oops. Around. fingers. There we go. So because it is a six-sided figure, so if it has 6 vertices, it's going to have 6 sides, and 6 sides is a hexagon. Now, one thing that's interesting about this is that I can figure out this length of them if I do something a little different. If I make triangles here, so I'll make this one is yellow, this one here I'll make orange so that I can kind of keep them separated. Just going to keep going yellow, orange, yellow, orange. And it's going to tell me the slope or length, and they're all going to be exactly the same. Oops. It's going over 3 and it has a 1. Whether the direction, it doesn't matter. If it's got a 3 and a 1, that means that when I square that, there you go. There's my last one, my orange one. There we go. They have all the same meaning. If I were to draw one over here, one of the sides is 1, one of the sides is 3. And it doesn't matter which is which, because 1 squared plus 3 squared, no matter the order, it's going to equal that side, and I'll call it D squared. And they're all going to be the same. So not only is it a hexagon, it's convex, but I can put these tick marks on all of these. They're all the same. And we can call this a equilateral hexagon. So that is it for Classifying Polygons 1.6. If you have any questions, reach out, and I will see you guys later.